This video is to walk you through the notes for the unit Equations and Inequalities. To start you off, I just want to go over very quickly the learner progressions. So it's broken up into two different pages. For the most part, we are talking about being able to solve one-step equations and solving one-step inequalities. So that's the two right here. And then also being able to interpret one-step equations in the real world, right? And being able to sub in some values and determine if it makes the equation true or not. And then being able to identify inverse operations and their purpose. And lastly, being able to graph a solution set. So when you have an inequality, can you graph it on a number line? So to start us off, what is an inverse operation? We've already talked about this year. Inverse operations is just kind of a fancy way of saying the opposite operation. It will undo something. So if you look on the examples here, the top example is inverse operations, addition and subtraction, right? If I give you $3 and then I take away $3, it's like it never happened, right? If you look down below, they say the same thing. We're opposite. So an inverse of multiplication would be division. Division would be multiplication. If I have a pile of money and I multiply it by 3, I make it 3 times bigger, right? But then I go ahead and I decide to take that pile of money and I divide it into 3 sections. I will be back to the amount I started with. So they just kind of undo each other, okay? Solving for an unknown. How the heck do we go about doing this? This is what kids want to know. As soon as we start talking about variables, how do we figure out what the variable is worth? Okay. So, in order to solve for an unknown, your whole goal is you want to isolate the variable, which just means you want to get it by itself, right? So, I have x plus 10 on one side of my equation. I want to get x all by itself or isolate it on one side. Okay, so how do we do that? Well, this is how we do it. We end up going through and doing the inverse operation. So, whatever is being done to your variable, you want to do the opposite of it. Okay, and that'll cancel it out. So, right now I have a variable and I'm adding 10 to it. So, the opposite or inverse operation for adding 10 would be to subtract 10. Okay. And then if you notice on here, it says it's a balancing act. So whatever you do to one side, you have to do to the other side. So when you're practicing with me, I always take my equal sign and I draw a line just so I remember whatever I do over here, I have to do to the other side. It's just a great visual, but definitely not required. Okay. Now all of a sudden, I had 10, but I took 10 away. So that cancels out on this side and leaves me with an isolated variable. And then the only thing I have left to solve is what's on the other side of my equation, 12 minus 10. So now I know that x is equal to 2. Okay, so again, we are using those inverse operations in order to get the variable by itself, okay? Another part of your learning target is just being able to solve for an unknown variable. How can you use properties of equality to write an equivalent expression? And this sounds really fancy, but if you break it down, it's super common sense. Okay, so if you look at this, there's 4 different boxes because there are properties for addition, subtraction, multiplication, and division. And basically, it's just saying in every single box, whatever you do to one side, as long as you do it to the other side of your equation, it ends up staying balanced or it ends up staying equivalent. Each side is equivalent. So if I start out with 7 plus 3 on one side and 10 on the other, right? They equal one another. 7 plus 3 is 10. So this is 10 equals 10, right? Well, if I go about trying to mess with this side and I say, hey, I want to add a to this side, well, I have to add a to the other side in order to keep them balanced. It's the exact same thing over here. If I decide I want to subtract a certain amount, then I have to subtract that same amount from the other side. Okay. If I'm going to multiply one side by a certain amount, then I have to multiply the other side by that same amount. That's all this is saying, right? So in order to stay equivalent, whatever you do to one side, you have to do to the other. So if I happen to have 8 plus 4 equals 12, right? These are equivalent to one another. This side is equal to 12, and if I solve this, it's also equal to 12, right? Well, if I decide that I want to take both sides and multiply them by 2, right? As long as I do it to both sides, they're going to stay equivalent, right? Because now this side equals 24 and this side equals 24. So as long as you're doing the same thing to both sides, they're going to stay equivalent. That's your main goal right there, okay? Oop, Testing solutions to equations. This one's super easy. All you're doing is plugging in a provided value, okay? So here's an equation, because there's an equal sign, and I'm going to plug in each of these values to see if it gives me a true solution or not. So all that means is where I see x, I'm going to sub in or plug in the value 5. So remember, this doesn't mean 55. This means 5 times 5, right? If x is equal to 5, then that means 5 times 5 minus 3. And then on the other side, I don't have 45. I have 4 times 5 plus 3. Okay. So all I'm doing is plugging in, and then I'm going to solve and see if it makes a true statement or not. So if this is my equal sign, whatever I get over here should equal whatever I get over here if it's a true solution set. Okay. So I know 5 times 5 is 25, and then I'm going to subtract 3 in order to get 22, right? So my whole goal is, if I solve this out, will I get 22? So if I look on here, I have 4 times 5, which gets me 20, and then I have 3 more to add. Do I get the same amount on this side? I do not, right? So is this value a solution? No, it is not. It doesn't actually make a true statement. Okay, so that's what my solution set with x equals 6, right? So I'm going to plug in a 6 here. 5 times 6 minus 3 and 4 times 6 plus 3. Notice I am making sure that I'm multiplying them out. I'm not just saying 46. I'm saying 4 times 6. I'm not saying 56. I'm saying 5 times 6, right? So 5 times 6 gets me 30. And if I subtract 3 from that, I'm left with 27, correct? Now, my whole goal is if it's a true solution, I will get 27 on the other side as well. So let's try it. I know that 6 times 4 will get me 24, right? And then I have 3 left to add to that, and that will give me 27. So this means that x equals 6 is actually a solution. Okay, so I'd say yes to that one. All right. And last one, x equals 7. So 5 times 7 minus 3 equals 4 times 7 plus 3, right? So I know 5 times 7 will get me 35, right? Minus 3. So I have 32 on this side. Let's see what we end up with on the other side, right? So 7 times 4 is going to get me 28, right? Plus 3 more, which gives me 31. So this one does not work as well. I would say it is not equal to, so it is not a solution set. So that is substituting. And just to go back real quick, on the bottom here is just another example, right, of how you can sub in, starting off with your variables and then just plugging in what they give you and rewriting it to solve it. Okay. And then down on the bottom, plug in the provided values to determine if the statement would be true. Does each side of the equation end up equaling one another? That's your main goal, okay? So here's some practice problems. This video actually takes you through all of those again, in case you want it later. And then we're on to actually solving one-step equations. So I call it Dorito math. You have to show your work, okay? Obviously, if you look at these, you should be able to just do these immediately in your head by 6th grade, Okay. For the most part, I think kids will quickly be able to just tell me the answer. This is not about the answer. Okay. If you just give me the answer, you will not pass this unit. You will have to start over again because my purpose is to train you in the actual steps that you need to follow in order to solve algebraic equations and expressions. Okay. So again, you have to show the Dorito math. I just call it that, but it's basically showing your work in order to pass this unit. Okay. We always end up having stubborn kids every year, and I'm just promising you that you will have to start over. Okay. So, again, when you're trying to solve one-step equations, I'm going to very simply put this, but you're going to identify where your variable is, right? Figure out what's being done to it, right? And then you're going to do the opposite. um, Okay, so find your variable, what's being done to it, and then do the opposite to both sides. Okay. If you actually go through and you watch that QR code up at the top, they go through and they have it nicely typed out for you. And when you meet with me, we'll do the same thing, but just for this purpose. Okay. So here's my variable. I found my variable. What is being done to it? I'm adding 5. Okay. So what's the opposite of adding 5? Subtracting 5. And I need to do that opposite to both sides, right? The reason why you do that is because if I add 5 and then I take 5 away, it's like it never happened. Okay. So it leaves me with my variable isolated, right? All by itself. And then all I have is to solve for the other side, right? Okay. This is Dorito math, right? I started out with a slightly longer equation until I finally get my variable isolated at the bottom. When your problems get bigger, your Dorito shape will take more effect. But just so you know, if you're thinking, how the heck am I supposed to show my work on this? Okay. I'm doing another color just so it stands out. All right. So again, right, find your variable. My variable is A. What's being done to A? I'm subtracting 10. What's the opposite of subtracting 10? Adding 10. And whatever you do to one side, you have to do to both sides, right? So I'm going to add 10 to this side. And the whole purpose of that is because it cancels out on this side and leaves me with my variable isolated. And all I have to do is solve the other side, which is 22. It's just really hard to see. Okay. Next one. I'm finding my variable k. What is being done to k? Well, it's shoved up against 5, so that means multiplying, right? So the opposite of multiplying is to divide. Okay, if I'm multiplying by 5, I need to now divide by 5. Okay, so it's the exact same thing. What was my variable? K. What's being done to it? I'm multiplying by 5. So I need to do the opposite of multiplying by 5, which is dividing by 5. And I have to make sure I do that to both sides. Sorry. So doing it to both sides, I need to divide this side by 5 now as well. Okay. And the same thing is up here, right? Why did we do that? Because 5 over 5, 5 divided by 5 gives me 1, right? 1k. 1k, right? They canceled each other out. They left me with my variable all isolated by itself, right? And now I have 35 divided by 5, which is 7. Okay. And then the very last one, you guys, here we go. B divided by 3 equals 10. So what's my variable? My variable is B. What's being done to it? I'm dividing by 3. What's the opposite of dividing by 3? Multiplying by 3, right? And whatever you do to one side, you have to do to both sides. So I'm also going to multiply the other side by 3, right? So now I've divided by 3 and multiplied by 3, which ends up canceling out and leaving me with my variable isolated. Okay. So now 10 times 3 is 30, and I know B equals 30. Again, if I had like pretty paper out, all of these would show slightly Dorito style, but it's not quite as obvious on my screen because my handwriting is terrible on this laptop. Okay. Okay. So again, here are more practice problems. And then this QR code up at the top, if you scan it, it will actually walk you through all of these practice problems. My main thing is just to remember, you are going to do the opposite operation to whatever is being done to your variable, and you need to do it to both sides, okay? The next section is being able to write equations from word problems. So this one's always a little bit tricky for kids. Writing equations from word problems is kind of like a step-by-step breakdown here, just to help you out. So let's go ahead and jump in and we'll talk them out, okay? So here's your first problem. A new one-year membership at Rexplex costs $160. Okay. That's what the whole month or whole yearly membership is, right? 1 year, 160 bucks. You have a registration fee of 28 bucks and that's paid upfront. So as soon as you walk in, they're like 28 bucks, give it to me now, right? Got to give it right off the bat. And then the rest of that $160 is going to be paid monthly. So how much do new members pay each month? Okay. So switching colors. All right. Define the variable. What do we not know? We don't know how much we're paying each month. So I'm going to use M for my monthly payment. We don't know the monthly payment, so I'm going to use M for my variable. Determine the constant, if there is one. Are you going to have a number all by itself in this math problem? Well, if you think about it, I also try to look and see, okay, I do have a number 160, right? And I have a number 28. Are either one of these going to be like on the answer side, like the final cost of everything? 160 is going to be my final cost. That's where everything has to equal at the end of the year. Okay. So that's why I know my equal sign is going to be followed by 160. That's what everything over here has to equal when I'm done with it. Okay. So now I'm just left with, okay, I figured out where 160 goes. I know I'm looking for monthly payments, right? I don't know the monthly payments. Boop, 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 don't know the monthly payments. And then what is 28? 28 is paid up front. So am I paying $28 every month? Do I want to shove that up against my monthly rate and say, okay, every single month I'm going to pay 28 bucks? No, that's not what I'm saying. I'm not saying 28 each month. I'm saying 28 is paid up front. That means it's a one-time cost. That's what that means. So if I'm only paying it once, I'm literally like throwing down $28 on the counter once, and then I'm going to add that to whatever my monthly cost is. And at the end of the year, it's going to be 160 bucks. Okay, so this is my overall equation, right? I like to look for what's my variable? Can I tell what it all has to equal in the end? And then I go from there. Okay. What is the rate? Or look for something that is for each or per or something that will repeat. What repeats? My monthly rate will repeat, right? So I need my monthly rate to repeat. How many times do I need it to repeat? We don't know what it is, right? But we do know it has to be for an entire year, right? So if I'm looking for a rate to repeat, I'm going to need this to repeat 12 times, right? The monthly rate could be $2. The monthly rate could be $500. It doesn't matter. The monthly rate has to repeat every month for 12 months straight. That's what a year means, right? So this is what it's going to end up being all together. I'm going to have a flat, I keep trying to flip this color. I'm going to have a flat rate of $28 laid out on the counter, right? And then they say, okay, besides this $28 that you just gave us, every month for 12 months straight, you're going to pay us a certain amount of money. And when you're done, it's all going to equal 160 bucks. Cool. Okay. So hopefully these little step-by-step look fors kind of help you out. I'm going to erase it. So if you want, you can screenshot it right now. Okay. I just like to keep things clear. All right, here's your next one. Juan's cell phone company charges $35 a month, right? Per month. That's our rate, right? They charge $35 per month for phone service plus 50 cents for each text message. It sounds like it's in the 90s. I don't know anybody that does that. Okay. Unless it's like a crime burner phone, maybe that's how they work. I'm not sure. Okay. So a phone service plus 50 cents for each text message. So when you say each, that's also a rate. Okay. Means it's repeating, right? That cost of 50 cents will repeat for every text message. That $35 will repeat for every month. Okay, these are rates when they repeat. Okay, how many text messages does Juan send in a month if his bill was 52 bucks? So again, I always say, can you determine what goes on your equal side? What is it all going to have to equal when you're done? Is everything going to equal 35 bucks when we're done? No. 35 bucks is a part of it plus this 50 cents for each text message. So that is not our final cost. Our final cost is $52 for the month, right? Okay. So how did we get the 52 bucks? We know for sure we paid a flat fee of $35, right? And then we're going to add 50 cents per text message or for each text message. So I personally would put a T for text message, but since I'm like drawing this on my computer and my handwriting might not be as obvious, I'll just call it an M for a message. So he's going to pay 50 cents. That's my little decimal sign, right? 50 cents. Bloop, bloop, bloop. 50 cents. That's so sad. I need to like just write like a big, okay, here we go. Let me write it so it actually makes sense. Okay. So we said $35. I'm going to write it a lot smaller plus that 50 cents per text message that we don't know. We don't know how many text messages there are. So I'm going to use it as a variable. The messages, we don't know how many, but no matter what, per message, it's 50 cents. So that's why they're shoved up against one another. Okie dokie. And then when we're done, it'll be $52. I just had it really spaced out. Okay. Take a screenshot if you want, right? If you look back on this, we have our constant, right? We definitely have a rate. This is 50 cents per message, right? Okay. And I'm going to clear this last one. Friendship's soccer team purchased uniforms and equipment for a total cost of $912. The equipment costs $612. The uniforms cost $25 each. There's that word. We know a rate is coming in if we're going to do each, right? $25 for each uniform. Okay. How many uniforms did they purchase? Well, I can tell right off the bat what my total has to be. Okay. What's the total after everything? The total cost is $912. Okay. How did they come up with that total? Well, they bought some equipment for $612, right? $612 flat rate, right? Here's your cost of your equipment. Then you have a certain unknown amount of uniforms, right? That's what we're trying to figure out. How many uniforms did they purchase? We don't know. So that's going to be our variable. What variable could we use for uniforms? A U? That's brilliant. Okay, so my unknown amount of uniforms is going to be U. Okay, I'm going to shove it up against the cost to represent multiplication, right? We are paying 25 bucks per uniform or for each uniform. So that's why it's multiplying right here. Okay. Again, take a screenshot if you need to. This should walk you through the process. Okay. There are more to actually go through. However, I am going to give you guys the next page to do on your own. There's a lot of them. I want to be able to save them for our small group as well. Okay. And then I know it does say to go through and actually solve them, right? Write the equation and solve. We did not take the time to do that because it's going to come up in a few more of our practice pages. Okay. There in your notes, you also have optional challenges. Okay. So if you look, I put quite a few on there because a lot of you guys are ready to push on beyond a one-step equation. That's fine, but you still have to show your work properly. Otherwise, there's no point in doing it because it's basically busy work, right? You need to be able to do it with the correct format in order for it to count towards a in progress or mastery score. Okay. So if you would like any of the optional challenges, I'm going to save that for a different video just so I don't bog down this video. Okay. Moving on to the last section. So we just did equations. Right now we're doing inequalities. Inequalities are all the other symbols and possibilities out there. It's basically saying anything but an equation, all other options besides an equation. Okay, so you could have two numbers you could have a number less than another number. You could have a number that's worth greater than another number. Anything that's just not equal to. Okay. Um, so this right here is a fabulous screenshot page, just so you can refer to all the time with your iPad. Obviously, you could dog ear it in your notebook as well because it's really important. Okay. So when you go through and you solve one-step inequalities, you're doing the exact same thing as you did with equations. So the fabulous thing here is just getting comfortable with reading them and knowing your actual symbols and what they mean. So I always say, okay, if you know that this is the less than sign and this is the greater than sign, these two are like they had a baby with the equal sign. Okay. So it has traits from both parents. This is a greater than or equal to, and means less than or equal to. And we'll get into that in a little bit. Okay. So just to kind of show you, I'm not even going to go through all of these because it's so much like equations. Where you would normally see an equal sign, okay, you're now going to see an inequality symbol. This is the less than symbol. This is the greater than or equal to symbol. This is a greater than or equal to symbol. Notice this is where I'm splitting them up, right? So this says x plus 3 is greater than 7. So whatever this side is, it's going to be an amount greater than 7 when we figure it out. This says x minus 2 is less than 3. So it's saying once we figure this out, the number is going to be less than 3. This says x minus 6 is greater than or equal to 4, which means, see how there's the equal to sign, right? It means when we solve this, it's going to end up being a number that is either equal to 4, so it could be worth 4, or a number greater than 4. Okay, so this side could be 4, this side could be greater than 4. Same thing over here, right? This says 10 is greater than or equal to x minus 1. So it's saying when we solve this side over here, right, it's going to end up either being equal to 10, because there's that equal sign. It might be equal to 10, or it might be something that is less than 10. Okay. So all I'm doing is going through where I see the inequality sign and I am splitting them up, just like I did with an equation. Okay. Now all I got to do is the exact same set of problems or same set of steps. So in this problem, where's your variable? There's your variable, x. What's being done to your variable? You are subtracting 2. Okay, so what's the opposite or inverse operation for subtracting 2? The opposite of subtracting 2 is to add 2. Okay, and once you figure out that, you have to do the same thing to both sides, right? So the reason why you do that, this all canceled out, right? If I take away 2 and then I give 2, it's like it never happened. Now all of a sudden I'm left with my isolated variable. I have 3 plus 2 on this side, which gives me 5. The only thing different, you guys, is I'm not bringing down an equal sign. I'm bringing down the inequality symbol. So whatever my variable is, it's going to be less than 5. That's what I'm saying. Okay. So it means if I'm going to plug something in here, it has to be a number less than 5 to make it true. Okay. Because think about it. If I put 5 here and I take away 2, do I end up with something less than 3? No, I actually get 3. So that would not make a true statement. Right? If I put in a 4 here, which is less than 5, right? If I put a 4 here and I take away 2, I end up with 2, which is less than 3. So that makes it a true statement. All right. That's what they're saying. You have to plug in a number for x that is less than 5. Okay. Anything more than that, and it won't be a true statement. So again, over here, where's your variable? Your variable is x. What's being done to it? You are taking away 6 from x. So I'm going to do the opposite, and I'm going to add 6. And remember, whatever you do to one side, you have to do to the other. So now these have canceled out and left me with just x, right? And I'm going to bring down my greater than or equal to symbol. And then I'm going to add 4 plus 6 to get 10. Okay. And all this is saying is whatever number I plug in here has to be either 10 or greater than 10 for this to be a true statement. Moving on. What am I doing to my variable? I'm subtracting 1. So I need to do the opposite or inverse operation. And I have to do it to both sides, right? So that means this cancels out and leaves me with just x. I'm going to bring down my my inequality symbol, and I'm going to solve on this side to get 11, right? So this means this x has to be less than or equal to 11 in order for it to make a true statement. Okay. I'm going to try a different color just to spice it up. Okay. So what's your variable? X. What are you doing to it? You are adding 3. So I'm going to subtract 3. And whatever I do, I have to do to both sides, correct? So now I'm left with x. Bring down my operation symbol. And 7 minus 3 will get me 4. Okay. Here's my variable. I am adding 2, so I need to do the opposite operation, which is 2. And whatever I do to one side, I have to do to the other. So that leaves me with my y isolated because they cancel out. Bring down my operation symbol, and I'm left with 15 on this side because I did 17 minus 2. And then the final one, here's my variable. I'm adding 9, so the inverse would be to subtract 9, right? And I have to do that to both sides, right? So these cancel out and leave me with m. I'm going to bring down my inequality symbol, and now I'm going to actually subtract them out, right? Think about what all of these mean as we go into our next step, because our next step is going to be actually like translating them. Okay, so now we have the words written out. Can we actually write them down as an actual inequality? Okay, so I have some examples for you, and then we can run through the rest of them together. So I have x is less than or equal to 56. So I have x is less than or equal to 56. So notice you have the words that are going to tell you what symbol to put in there, right? So I have 53. I'm going to put it over here since I write bigger. 53 is greater than or equal to x. So I have to do a greater than or equal to symbol. Okay. 95 is equal to x. So that one's just quick and easy. 95 is equal to x. So that's not an inequality though. Negative 82 is greater than x. So I have negative 82, and it needs to be greater than whatever value is x. Okay, so you guys can go through and create your own as well. I'm going to stop there. because I really want to get into the graphing. Okay. So when we're trying to graph inequalities, there are some scenarios here, which I gave you just as examples to help you out because there's like word problem scenarios. All the word problems have the number 7 in them, and you get to kind of see what they look like based off of their wording. Okay. But for right now, I'm going to go through and I'm going to start on this one, I think. So I'm going to write an inequality that is based off of this graph. Okay. So I'm going to show you what number is my circle over. Okay. My dot. So see how this starts? The blue starts above the 4 and it's a circle, right? So I know that what I'm graphing, I always say X represents what I'm graphing. What I'm graphing is it's starting at 4, right? And then it's going in this direction. The fabulous part of this is if your graph is going in that direction, that is also the direction of your inequality symbol. Cool. So I didn't even have to think about that. So what I'm graphing in this one, if you notice the graph for the blue goes in that direction. So that's the direction of my arrow. They match, right? And then it's above, it starts at -16. So that's what I'm going to put over here, right? I'm graphing something to compare to -16. What I'm graphing on this one actually starts over -20, right? And it goes in this direction. So I'm going to have it point the same way. Same thing here, right? What I'm graphing points in the right direction. So I'm going to go in the right direction here as well. And it starts over -2. Okay. Those are just helpful hints. We're definitely not done yet, though. Okay. So the main thing I want you to know is if you have a circle and it is filled in all the way, okay, it's going to represent either something that is greater than or equal to, or it's going to represent less than or equal to. Okay. I always say if you have an equal to symbol, you have something extra there, you're going to have something extra on the inside here. It'll be filled in. Okay. If you just happen to have a circle and it's not filled in, it's just an open circle, that means your symbol is going to be less than or equal to, or sorry, greater than or less than, no equal to parts. Okay. So if you look, this dot is filled in. There's something extra on the inside of the dot, so I need something extra here. It also represents equal to. This dot is filled in. It has something extra on the inside, so this symbol has to have something extra. It's also equal to. This one's filled in. It has something extra on the inside, so it has something extra down below as well. Okay, it's an equal to. This one is not filled in, so it does not get the equal to symbol underneath it. Okay. So the way I'm reading this is the numbers that I've graphed are less than or equal to 4. So all the numbers that I'm representing on this graph are less than 4 or equal to 4. So hopefully you can see that now, right? Because all the numbers that have the blue line on top of them, right, are less than 4. And the circle's filled in, so we're also including that 4. Okay. X is greater than or equal to -20. This means all the numbers that I graphed, all the numbers represented in blue that I graphed are greater than -20 or equal to -20. So all the numbers are greater than -20. And this is filled in, so I'm also including -20. This X is greater than -16. This means all the numbers that I graphed, all the numbers with the blue above it, are greater than -16. Okay. I'm not including -16 though, because it's not filled in. It's just any number that is greater than that. And then X equals greater than or equal to -2, right? This is showing you all the numbers on my graph, everything I've represented with my blue line. They're all numbers that are greater than -2 or equal to -2 because I put a circle there. Okay. So when I say give a real world example for each graph above, record them below, that's something that we'll work on together in our small groups. You could take a screenshot of this if you want to, or fill it out as you're listening to this. But this is an example of what I mean by that, right? So if you're given a graph, here's a scenario where the most number of books a student read was 7. Okay, so at most they read 7. So that means it could include 7 or any number less than that. So that's just another way of diving into the actual explanation, right? Mary spent more than $7 at the mall. So we're not including 7, right? Our circle's not filled in. I don't want to include 7 in my graph because it's any number more than 7. She spent more than that. We don't know how much, but it was definitely more. So this graph would represent more than. Cool. The boys ran 7 miles or more. So that's why it's filled in. We're including boys that ran 7 miles. So the 7 is included in our data. And then it goes in this direction to the right because it's all the numbers that are greater than or more than 7. And then this teacher lived less than 7 miles from the school. She didn't live 7 miles from school. She lived less than that. So I don't want to include the actual number 7. So I'm leaving my circle open. But I do want to include any numbers that are less than 7. Cool. So go through, you guys can read these out, try them out on your own. You can even just, if you want, draw a line to each one to kind of save you time so you don't have to rewrite them. Okie dokie. And that is it.